Hello guys, so today we have to defuse the bomb. Yes, this is the title of the problem and that's what we are going to solve today. There is a bomb and obviously that bomb should not be, exploding. It should be, diffused. And in order to diffuse that, we have to, decrypt an array, circular array code, and the way to diffuse it is that you have to if k is greater than 0, replace the ith number with the sum of the next k numbers. If k is greater than 0, replace the ith number with the sum of the next k numbers. So k plus 1, k plus 2, and so on till k plus I plus k. Sorry, I plus 1, I plus 2, and so on up till I plus k. If k is less than 0, replace the ith number with the sum of the previous k numbers. So I minus 1, I minus 2 till I minus k. Okay. And if k is equal to 0, we have to replace the ith number with 0. So this is what we have to do. And how are we going to do this? So it's simple, if we are let's say first of all we find the length of the input array. So this is the length, and then we declare this result array. This is equal to new int array n, and then what we will do, that if k is equal to 0, return result. Why? Because if k is equal to 0, we have to replace the ith number with 0. By default, all the indexes in this result is 0, so that's what the condition asks for k is equal to 0. Otherwise, what we will do, we will take a loop, and in this loop I is equal to 0. Okay, I less than n is the last index, plus plus I, and then in this we'll declare int sum is equal to 0. And now there are two cases. If k is greater than 0, so if k is greater than 0, then what we will do, we will have to, if k is greater than 0, replace the ith number with the sum of the next k numbers. We have to do the sum of the next k numbers. So to find the sum of the next k numbers, j is equal to 1 and j is less than equal to k plus plus j. And what we will do here, sum plus equal to code of I plus j, not equal to I plus j. So I plus j, the problem with this sum of I plus j is that they can go beyond the index range of the code, given code array. How to wrap that around? In order to wrap that around, we have to do a mod operator, and that is %n. Perfect. And what is the other case? The other case is if k is less than 0. So in this case, what is the thing? The thing here is that we have to go from the we have to go from the same int j is equal to 1 and j is less than equal to math dot absolute value of k. Okay, and then we have to do plus plus j, and then what we will do, we will do sum plus same thing code. Now in this case I minus j. Why minus j? Because we have to go to previous k numbers, I minus j, and then plus n. Okay, so why are we doing plus n here? So we are doing plus n here. Suppose the array length is of let's say is of size 5. So in total there are 5 elements, so indexes will be from 0 to 4, and let's say we are at index 0 and k is equal to -2. So if k is equal to -2, we have to go to index -1, and k minus 1 is -1, and then k minus 2 is -2, because we are at k, the ith value is 0 and I minus 1 and I minus 2. These are the two indexes that we have to reach to find the sum of previous two indexes. but -1 and -2, these are not valid index values. So what are we going to do? In languages like Java, -1 and -2 are not valid index values. So what we have to do, that we have to wrap those values, and in order to wrap those values, what we are doing at all times, we are doing plus n. And you may think that by doing this we are disrupting the index range, but we are also doing going to do a percent n. So when we are doing percent n after doing this plus n, so plus n is, in all cases it is going to restrict, the negative, the negative things, -1 to minus n minus 1. These values are, made positive by the addition of this plus n, and then taking the mod of the whole sum by the percent n is going to, is going to make sure that everything is within that 0 to n minus 1 range. Okay, like this. And after this, what we will do, that we will keep this, result of I is equal to sum, return result. Okay, like this. So we have to declare this int j. Okay, perfect. So we can submit this. We can see that this is solving the problem correctly, but it is not a very optimum solution. And in order to achieve a better result, what can we do? So in order to achieve a better result, what we should do, that we should, see that, we are doing this sum for, repeatedly. Okay, in between two indexes, say I is equal to 0 and I is equal to 1, most of the elements in the sum are overlapping. Only the index, I plus 1 is coming out, and end plus 1 is coming in. So we can exploit this sliding window approach here. In the sliding window approach, what we do, that we, remove the start element and add the end plus 1 element to the sum window, and that's how we get the, some of the next uh, slot, next index. And in this, we are not performing the sum of the whole index range. We are only, removing the first start element and adding the end plus 1 element to the sum, to the given sum. And that's how we are able to get the window sum. And this window sum is this window sum is, this window sum is instrumental in having, in creating a overall sum of all the elements. Okay, so we should, we need to make some changes in this solution. And how are we going to do the changes? We will remove these. Okay, let's leave all these things. Int start is equal to 1, end is equal to k, sum is equal to 0. But if k is less than 0, then what? So suppose if k is less than 0, what happens? Suppose, imagine a, line. Okay, if k is positive, then start will be I plus 1th index, and it will go till I plus k index. Okay, but if k is negative, then we'll have to start from I minus 1th index and go till I minus kth index. So we have to go in the reverse direction. But here we want to have a common code. okay, a common code to handle both the scenarios. So our approach will not be starting from I minus 1th index and going till I minus kth index. What we will do, we will start from I minus kth index and then increment that I minus k plus 1, I minus k plus 2, like that, and we'll go till I minus 1th index. So we'll start from the farthest end. So even though we are calling it as start, it is the farthest end. Okay, so how are we going to do this? So see, I minus k plus n, y plus n. Remember, we don't want, minus 1 and minus 2 and minus n minus 1, all those values. In order to avoid those values, we are doing this plus n. Okay, and then end, what is the end value? End value is I minus 1 plus n. Okay, general formula, but I here is 0. Okay, so it is 0 minus k, and here it is 0 minus 1. So this is basically 0 minus k plus n is basically n minus k, and 0 minus n plus 1 is basically n minus 1. Okay, and we'll start our loop like this. For int I is equal to start, I less than end, less than equal to end, and then plus plus I, and what we will do, we will do sum plus is equal to sum plus is equal to code sum plus is equal to code I code I, yeah, that's it. And after this, what we will do, we will take one more loop. Okay, and in this one more loop, what we will do, int I is equal to 0, I less than n, plus plus I. Okay, and result of I is equal to the previous sum, and then sum minus is equal to, sum minus will be code of start percent n, like this, and sum plus is equal to code end plus 1, like this, and then plus plus start minus plus plus end also, because we have to increment the end value as well. Okay, and that's it. Yeah, nothing else we need to do. So I hope it is clear. So first of all, we are taking the length, then we are declaring the result array, which will be modified in the course of this solution. If k is equal to 0, we need not do anything, because as the description of the problem says, if k is equal to 0, replace the ith number with 0, but the ith number of the result array is 0 by default, and so we can return that default result array. Otherwise, we will declare int start is equal to 1, end is equal to k, and sum is equal to 0. So this is the declaration for positive. This is the this is the declaration for I should separate this out. Okay, it's better that if I separate this out. Okay, so int sum is equal to, let's say sum is equal to 0. So this is the overall declaration for sum of the particular window. So this is the window sum value. Okay, we'll be storing the window sum value in this sum variable. We will be storing the window sum value some variable. Okay, and these are the start and end. So these are the Windows start index and the end index of it. But if the k is less than 0, so see, usually we in a window we start from the start index and go till the end index. So our start index, we can think of the start index will be n minus 1 and end index will be n minus k. But if we choose our start and index in this way, then we'll have to go in the opposite direction. So what we are doing, we are taking the start the farthest end, and end is the nearest to the current index, and that's how we are making sure that we are always moving from left to right. And in order to the farthest end is taken as the farther end is taken as the start index. Okay, and the nearer end is taken as the end index, so that the direction of the movement remains same. Okay, and what we are doing after it, that we are taking the first window sum. So this doesn't require any first windows sum. And then after the subsequent, after getting the first window sum, what we are doing, the initial sum we are storing in the ith index, and then for every subsequent sum, what we are doing, we are removing the first element, removing the start element, start index element, adding the end plus 1 index element, and then we are returning the result. Okay, so we'll run this. So there is this mistake here. What is this mistake? Oh, this mistake is n minus k. So we should take this math dot absolute of k. Why we are taking this math dot absolute of k? Because k is less than 0, so n minus k will be becoming n plus k. So it is not a valid index value, and that's why we are getting 0, because we are starting from n plus k and going till less than equal to end, so which is not correct. So we should be doing like this, and let's me run it once more. Perfect. Let me submit this. Perfect. So this is what I wanted to show. This is a perfect display of sliding window sum. I hope you liked it. Happy coding, best wishes, keep coding.